Let's look at an absolute value greater than problem. For example, absolute value of x is greater than 5. So this means the distance from 0 is more than 5 units. So these numbers would work, but also these numbers would work. This is an or situation. We can either have the numbers down here or the numbers up here. So to do these problems, again, you separate it into two inequalities. So let's solve 3 absolute value of 2x minus 4 is greater than 12. So first I divide both sides by 3. Absolute value of 2x minus 4 is greater than 4. Now I'm going to set up two inequalities. The first one is the normal sentence, 2x minus 4 is greater than 4. And then you say or. And the way I remember it is to go switch, switch. I'm going to switch this sign and I'm going to switch this sign. So I say 2x minus 4 is less than negative 4. That will take care of this area down here. So solving each, I add 4 to both sides. It looks like a negative up there, it's not. Divide by 2, so I get x is greater than 4. On this one, I add 4 to both sides. Divide by 2, and I get x is less than 0. If you look at it on a number line, here are the answers you've gotten. Anything greater than 4 or anything less than 0. So in interval notation, I would write negative infinity to 0 or 4 to infinity. So again, when it's greater than, you're going to say switch, switch, and then your answer will come out correct. Let's do one more. Let's take negative 3, absolute value of x minus 2 is less than negative 9. So you get the absolute value alone on one side, because right now it looks like a less than problem. But when I divide both sides by negative 3, remember you switch the inequality sign. So x minus 2 is greater than positive 3. So now I set up my two inequalities, write the normal absolute value problem first without the absolute value sign. Since it's greater, it's an or problem. And then you switch, switch. So I'm going to say x minus 2 is less than negative 3. Solve both of those. I get x is greater than 5 or x is less than negative 1. On a graph, it would look like this. Any number greater than 5 would work. Any number less than negative 1 would work. I get negative infinity to negative 1 or 5 to infinity. One more example. Let's suppose you have negative 2, absolute value of x plus 4 is less than 8. Divide both sides by negative 2. We get x plus 4 is greater than negative 4. We have a greater than problem, so I'm going to split it. The original first, x plus 4 is greater than negative 4. Or switch, switch for greater than, so I have x plus 4 is less than positive 4. Subtract 4 from each side, you get x is greater than negative 8. Or subtract 4 from both sides, x is less than 0. When you look at this on a graph, something strange happens. Greater than negative 8 is here, less than 0 is here, or means all the answers you've written down. So my answer is negative infinity to infinity. I've written all those answers down, or I've graphed all those answers. Why did that occur? Because I have absolute value, which is a distance, is bigger than a negative number. Absolute value is always bigger than a negative number. So again, if you recognize it right at this point, you could put all real numbers, but usually we just solve and find the answer.